Hey y'all, welcome to part 3 on my series of Vectric software titles for the absolute beginner. Before we get started, let me just say that I am not endorsed nor sponsored by Vectric Limited nor any other company. I'm doing this series to assist the people who have never done anything like this before and hopefully help you gain a little confidence in yourself and your abilities when it comes to using this CAD CAM software. In this video, I'm going to introduce you to a few more semi-advanced tools, but we're going to keep it at a beginner's level in that we are going to create a simple project from beginning to end. So we'll start by going ahead and creating a new file. I've gone outside and I've found a piece of material that I want to use for this file, and that piece of material, it's a single-sided project. The piece of material I have is 15 inches wide in X and it's 13 inches tall in Y. And the thickness is 1/2 inch. I'm using inches. I'm going to set my Z0 to the top surface of the material, and my XY datum position for laying out this project will be the center of the material here. And I'm going to go ahead and accept everything else as it is. So we've got our project set up. What I'm going to do is I'm going to make a simple clock face. I figured by associating this with a project that everybody can wrap their head around, we might make some of these layout tools a little bit more realistic. This just happens to be the size of the material I have. What I want to do is I want to cut a 12-inch square clock that I can see from across the room. The first thing I'm going to do is go over here to under Create Vectors to draw a rectangle. Now I want to anchor the center of that rectangle on my 0, 0, X0, Y0. So it's already selected for me the anchor the center of my rectangle on X0, Y0. For my corners, I want to use square outside corners. Now, I could also use a radiused corner if I chose, and I would enter the radius here, be that 1/4 inch as it's set right now, 1/2 inch, 1 inch, whatever I like. Or I could radius those corners to the inside as it shows right here. And then again, I would choose the radius, 1/4 inch, 1/2 inch, 1 inch, 2 inch. For this project, however, I'm going to go ahead and choose a square corner because I want to keep it simple. Down here, this rectangle is going to be the outside profile of the final project. So I would like to go with 12-inch by 12-inch square. So that's the size of rectangle we're going to make. We can go ahead and click on Create, and we see out here now we've got a 12-inch by 12-inch square centered on my X0, Y0. I'll go ahead and close that form. I'm going to use simple dots. I will pocket out holes and I will glue pieces of dowels into those holes to indicate the times 12, 1, 2, 3, etc. I'm going to use a 3/8 inch dowel up here at 12, down here at 6, over here at 3, and over here at 9. And I'll use 1/4 inch dowels to mark the other times, 1, 2, 4, 5, etc. So the way I'm going to do that is I'll start by drawing one circle to base everything on. So we come back over here on Create Vectors. vectors and we'll click on Draw Circle, and that opens up this form. Now, as you can see, our choices are pretty limited. I can select the center point, where I'm going to place the center of that circle. I can select whether I'm going to enter a radius or a diameter, and then I have what that radius or diameter will be. I want to put the center point of this circle here on my X0 line. So that's already entered for me, and we're just fine right there. But I want it up here close to the outside without going too far out. I don't want to get out here in the edge. So let's take a look at, you see, I've kind of got a set of crosshairs, and the X just underneath the cursor is reading 0 because I'm on my X0 line. And my Y has a reading right in there of about 5 inches. I think I'm going to go ahead and I'm going to call that a good place to start. So we'll look at X0, Y0. Well, let me move up here a little bit more. Yeah, I think I'll stick with X0, Y5. So I'll come back over here, and it's already there by coincidence for me. I'll go with X0, Y5, and that's where the center point of this 1/4 inch circle is going to go. I'll go ahead and click Create, and there we have our first circle at the 12 o'clock position. Now I'll go ahead and close it. So I've got my 12 o'clock position marked. Now what I'm going to do is create 11 more copies of that circle, evenly spaced around a full 360-degree circle. And the way I'll do that is select this circle, then come down over here under Offset and Layout to this icon right here, Circular Copy, create a circular array of copies. I'll click that icon and it opens up this form right here. You can see that the cursor around our circle has changed to the transform and move mode. The selected object, it gives me the size here of 1/4 inch by 1/4 inch. And now I need to select the rotation center. What this is I'm going to do an array of copies, but what's the center point that array is going to be based on? And I want that to be X0, Y0. And you'll notice it made this little symbol right here. That's telling me that that's my rotation center. So all the copies I create will be based on this center. Now I want a total number of 12 to include the one that we've already drawn, and I'm going to use a total angle of 360 degrees in that circle. We can get into some of these other choices at another time. I'll go ahead and click Copy, Close, then click Off, and we can see we have 12 evenly spaced circles. I did that because it's an easy way of placing these circles out here. These are going to be 1/4 inch dowel, as I said. My 12, 3, 6, and 9 are going to be 3/8 dowel. So I don't actually need these. I need to resize them. The easiest way to do this in this case is, yes, I could go to each one individually and increase their size. But I'll just go ahead and select these three by selecting the first one, hold down Shift, select this one, and tap Delete on my keyboard. That leaves me with this one here, which I can then resize. then create a circular array of 4 dots. So we'll go ahead and do that. I have it selected. We'll come over here under Transform Objects, and I'll click on that icon. Now, when this form opens up, I have relatively few options. I've decided to keep the anchor point here in the center. I need to make sure my link X and Y is checked here. With this checked, anything I enter here in the width or percentage will also be entered here, or this percentage, meaning it'll keep that circle a circle and keep it in proportion. If this was unchecked and I entered a new amount up here or down here, that would be the only axis that would be affected. So it would change the shape. I don't want to change the shape, I just want to change it to 3/8 of an inch, so I'll keep my link XY checked. And I'll come up here and I'll use one of the calculators built into the Vectric software again. I can't remember what the decimal equivalent of 3/8 of an inch is off the top of my head, so I'll type in 3/8, then tap the equals sign on my keyboard, and there we go. I'll click Apply, then I can close this form, and I have a 3/8 of an inch circle here. Now I need to go ahead and create the array to put one here, here, and here. So we'll go back down to Create a Circular Array. Click on that icon. The size is correct. However, I still want my rotation center to be 0.0, X and Y. I now only want to create 4 copies total around a 360-degree circle. And we'll go ahead and click Copy, close that, and there we go. I have a 3/8 inch circle here, 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 and here. Now I have one more circle to draw, and that's right in the center where my clock movement post is going to come through. Now I've got my clock movement and I've measured the post and I know that it's 3/8 of an inch. But I need to go a little bit bigger than that, just so that threaded post will slip through there without me having to hammer on it or press it through. So I'll go back up here to Create Vectors. We'll draw another circle. Again, I wanted it X0, Y0. And I want the diameter to be just a little bit larger than 3/8. So remembering from when I converted 3/8 a second ago, I know it's 0.375, and I want to add about 5/1000ths to that. So I'll go plus 0.005, then tap equals. So it's going to create a 0.38 inch circle right here in the center. Diameter. Let's create it. And there it is. We now, believe it or not, have all of our vectors drawn and placed to make our clock face. Now I'm going to introduce another tool that's used for simple convenience. These holes here, here, all these 1/4 inch holes, and this center hole are going to be drilled all the way through the material. Because I have a limited supply of dowel, I'm actually going to cut some 3/8 inch plugs out of some material that I have for these 3/8 inch holes here at my 12, 3, 6, and 9. So I'm going to pocket these about 3/8 of an inch into the material. I'm not going to drill them all the way through. So in order to do that, just for my convenience, I'm going to group all of these together by selecting the first one, holding down Shift, then select the others. Then come over here under Edit Objects to this icon right here, Group Selected Objects. And I'll just click that icon, and you'll notice that the vector changed from pink dotted lines to a pink solid line all the way around all 4 of them. Now I'll click off, and if I select one, I select them all. Now any change I want to make after this will be made to all 4 of these. If I need to ungroup them for some reason, I can come back over here under Edit Objects to the icon right next to it, which is ungroup those objects back onto their original layers, and if I do that, they go back to being pink dotted lines again, meaning that they are now separate objects that can be edited independently. But I want to go ahead and group these, so I'll reselect them by holding down Shift and clicking on each one individually. Come back and group them. Okay. Now again, these here are all going to be drilled all the way through. So what I'm going to go ahead and group all of them even though they're different diameters. So I'll start out over here and draw a box this direction. And if you recall from episode 1 of this series, if I draw from left to right around them, the vectors I'm selecting have to be completely inside that box. I let go of my left mouse button and all of those vectors are selected except for these here. They were not inside the box. Now I can come back over here and group those. And the same holds true here. If I select one of these, I select all of them. Now I'm ready to calculate toolpaths. Yes, it's that easy. We'll go over here, switch to the toolpath commands. Now again, I'll look at my material setup. My material is 1/2 inch thick. My XY datum is in the center. I want to change that, so I'll click the Set button. I'll change my XY datum down to the lower left corner. Nothing else will change, so I'll go ahead and click OK. Now we can begin calculating the toolpaths. I'll start with these here. We're going to do a pocket cut all the way through. So we'll come over here to this icon, which is Pocket Toolpath. Click on that. My starting depth is going to be 0 because I'm going to begin cutting on the surface of the material. My cut depth, I want it to go through the material plus about 5/1000ths of an inch so that I've got a good clean cut all the way through. So again, I'll highlight everything in that box and I'll type Z plus 0.005. Then when I hit the equals button, it does the math for me. For the tool, I'm going to use an end mill. Now, let me say something right here about my selection of end mill. This is a 1/4 inch hole. Using a 1/4 inch end mill, it's going to cut basically straight down. I have got to remember to use an upcut bit when I machine this hole. An upcut end mill will eject the chips and sawdust upwards out of that hole. A downcut bit will try to force them down into the hole that I'm trying to cut. That will create friction, and that friction will start burning. It will get that hot. I'm not talking anecdotally here. I'm speaking from experience. I don't know a fellow who did it. I did it. I started a fire on my CNC table, drilling straight down using a downcut bit, not knowing any better. Ruined the project, and I had to replace the spoil board. Do not drill straight down into a hole with a downcut bit. Use an upcut bit, always. Okay, enough with that soapbox. So I'm going to use a 1/4 inch end mill, as is already selected here. It's going to do it in 4 passes, that's fine. I'm not going to use a larger area clearance tool. The way I'm going to clear these pockets is offset. I have 2 choices here, offset or raster. They both have their place and they both have their uses. I find that when you're cutting circular objects, especially where the bottom is either non-existent or is not going to be seen, the bottom of the pocket that is, that offset is a good way to go. Offset is the bit will pick up and come over, start plunging into the center, and then start cutting in a circular motion. Drop down, then cut again in a circular motion. The other choice is raster. Raster is side to side with a cleanup pass for profile. That would mean the bit would attempt to come over here to this little circle, drop in, and then move side to side, back and forth, and then clean up the edges with a profile move. For this type of operation on a circular pocket, we'll go with offset. It's just easier for the tool. I'm not going to ramp the plunge moves. I'll explain ramps in another video. And we'll go ahead and we will name this tool path through hole pocket 1/4 end mill. I'll click calculate, and it's giving me the warning that the tool will cut through the material. We know that, we want it to. Click OK, and the tool path is calculated. And here again we have our red lines to show us the rapid moves. We have our dark blue lines, although they're very small over here, to show us where the tool is going to cut, and then we have the light blue lines showing us our plunge moves. And we can see the 4 separate steps this is going to take to machine out these holes. So I will go ahead and leave this set for maple. I'm not going to concern myself with a toolpath color or a machined area color on a through hole. We'll go ahead and we'll just preview this selected toolpath. And there we see those holes drilled all the way through. Okay. Reset our view here. Now we'll close this, go back to the 2D view, and we'll select this group. Now these, again, I'm going to use plugs. I would just soon not drill all the way through. I'm only going to drill these 3/8 of an inch deep. So I've got them selected, the entire group selected. I'll come back and click Pocket Toolpath. My start depth is again going to be the surface of the material, but I only want to go 3/8 of an inch. So I'll type in 0.375 since I remember that. I am still going to use a 1/4 inch end mill. Not going to use a large area clearance tool. Again, I'm going to use an offset clearance. And we'll come down here and we'll call this 3/8 pocket 1/4 end mill, and we'll calculate that toolpath. And again, we have our toolpath outlined here, and I'll preview it. And there we go. I'm not going to give this a toolpath color. It's not really necessary. But we've got a nice clean pocket here. Now if we look down below here at our XYZ display down here, as I mentioned in the last video, episode 2, and if you missed that one, I'll put a link up here somewhere. If I put my cursor, the point of my cursor down here in the hole, you see how that Z display down at the bottom that I pointed out down here, it changes to reflect the depth that that bit machined to. So now I can plug that with a plug of a contrasting wood and use standard dowel here in these, and I'll have a nice looking clock face here. So about the only thing that we have left to do on this entire project is our outside profile. Now our outside profile, we'll use a profile toolpath like we did in the last video. And again, our start depth will be the surface of the material. My cut depth will be Z plus 0.005. I'll hit the equals button. We'll cut all the way through the material. The tool, I'm going to use the same 1/4 inch end mill. I'm going to cut to the outside of this vector. I'll use a climb cut. In this video, I'm not going to do a separate last pass. I'm not going to add tabs, but if I were, this is where I would do them. I'm not going to do ramp leads or anything, but I am going to go check my corners and make sure I have sharp external corners selected here, because I want good sharp external corners. Then I will come down here to the bottom and name this cutout 1/4 end mill. Click calculate. It's warning me again that it will cut through the material. That's okay, I want it to. And now I'll go ahead and preview this toolpath. Double click to remove my waste, and there's our finished clock face. That is our finished project. We're actually ready to generate G-code, go outside, load this into our controller software, and machine this little clock face right here. Let me go ahead and straighten that out. We'll close our preview, and because all of these use the same end mill, I don't even have any tool changes to concern myself with. So we'll go ahead and we'll end this video right here. This was a demonstration to show you just how simple some of these projects can be. In the time it took to record this video, we not only designed but previewed and calculate toolpaths for a simple clock face. This is what I mean when I say you can do this. So I hope you got something out of this video. If you did, I do hope you'll give me a thumbs up down below. If you'd like to keep following this beginner series, or follow along with some of my other CNC adventures, I do hope you'll consider subscribing to my channel. As always, whether you subscribe to my channel or not, I'd like to thank you very much for watching, and y'all take care.